All right, so triangle similarity. What we have here is three different postulates, just like the five that we had for congruent triangles. We have three postulates for similar triangles, that if this is true, that we know the triangles are similar. So the very first one is just AA, angle-angle similarity. So if two corresponding angles are congruent, then the triangles are similar. So by these examples below, determine if they're similar. If yes, write a similarity statement. So pretty much for number one, we can find the angles in this triangle. So 75 and 74, add them together, subtract from 180. That will give us 31 here. So now we see that 75 and 31, we have two pairs of congruent angles. Now, obviously, that means that the third pair has to be the congruent, right? If we have two of them that are the same, that third one has to be the same. And we know that if we have three congruent angles, then that is that has to make a triangle similar, right? So if we have three sets of congruent angles, that was one of our definitions yesterday for similar triangles. So yes. And then we're also going to write a similarity statement. So you have to be very careful here, especially with your angles. But we're going to say that triangle ABC, and if I went from A to B to C, so 75, 74, 31, I need to do the same thing here. 75, 74, 31. That will be triangle DEF, which sounds really self-explanatory, and you're like, duh, Mr. White, they're just alphabetical order. They're not always going to be alphabetical order, okay? So be very careful with that. All right, so with number two, we have one set of congruent angles with V and Y right there, but we also have another one because we know that these are vertical angles. So this X is the same. So this is a little different because the triangles are kind of flipped. You need to be very careful with this. But we do have two congruent triangles. So yes, we know that it is similar. And then we're going to do a congruency statement. So what I would say here is be very careful with which direction you go. I'm going from V, which is one arc, to X, which is two arcs, to W, which is none. So it's 1, 2, none. So I'll have to do, let me get it here, VXW, and that is similar to the triangle from 1 to 2 to none. So that'll be YXZ. So it doesn't necessarily matter which order you do. You could have gone the opposite way. You could have gone any other way. As long as V matches up with Y, X matches up with X, and W matches up with Z, you're good. Okay? So then we have another postulate, SSS, side-side-side similarity. So in other words, we also know the second definition of triangle similarity is that all the sides were proportional, right? So if we know that all these sides are proportional, then we know that they're similar. That is also true. So we have QP, which is 3, PR, which is 4, and QR, which is 5. And that would match up with TS, which is 6, SU, which is 8, and TU, which is 10. So we can see that all of these, yes, that is a true statement. All of these equal 1/2. So if that is true, we know it is similar, and we can say triangle QPR is similar to TSU. Be very careful. Again, we're dealing with similarity, not congruency. So we'll do the same thing for number 4 down here. But again, be very careful. Sometimes they're not always matching up. And what I would say, maybe this triangle is flipped. Maybe it's inverted, whatever it is. If these triangles are proportional, the longest side is going to be proportional to the longest side on the other one, right? So the longest side here would be 35. So we're going to look over here, and that would be the longest side here, which is 28. So I'm going to put 35 up top, 28 on the bottom. And then you can also do the shortest side, right? So the shortest side over here will be 30. And the shortest side over here will be 24. And then lastly, there's only one other side remaining, right? So that would be 32 and 25. So we could check to see if those work. And again, you may be looking at me like, well, yeah, that's kind of easy. Like they're not inverted here, so it's no big deal. Well, actually, sometimes they might be, or sometimes they might be overlaid on top of each other, or different things like that. So I think the longest side, then the shortest side, and then whatever's remaining is a much easier way of doing this. So we have 35 over 28. You can divide those both by 7. that will give you 5/4. 30 over 24, you can divide that by 2, and that'll give you 15/12. So just automatically, we already know that these are not congruent. Well, I could divide that by 3, couldn't I? Yeah. So what should it have been? Oh, it's 6. It's 6. Geez, man, I'm out of it. Okay, so if it's 6, that will be 5/4. Oof, okay. Ouch. And then 32 over 25. I remember that this one doesn't work. I know. So this one right here, 32 and 25, there's nothing that you can divide by. So no, it doesn't work because they're not all similar. Yeah. Anyways, we're moving on. So side angle side similarity. This is the last one. Side angle side. And again, you see that the included side is in between, or the included angle is in between the two sides, right? So determine if the examples below are similar by SAS. They have to be, that angle has to be in the middle, and the sides still have to be proportional. So you have to check to make sure the angle's in the middle and that the sides are proportional. So we would have 8 and 6 and 20 and 15. And we're asking a question. We're asking, is this true? So 8 and 6 would divide out to 4/3. We can divide these both by 5. That would divide out to 4/3. So yes, this works. And we would say that triangle JKL, so I went, from the smallest side to the big side, is similar to triangle MNP. Right, and then this one, we know that we have angle A, which is used in both of these triangles, both the small one and the big one, right? So angle A is a pair of congruent angles. It's paired with itself. And then we just need to see if these sides are proportional. So we have 25 over 15 and 21 over 12. So we're just asking a question, are these proportional? 25/15 would simplify out to 5/3. And 21 over 12, we can divide them both by 3. That will be 7/4. So no, this does not work. They are not similar. So since the sides are not proportional, these triangles are not similar. So with this other set of notes, proving triangles similar, we're going to determine if they are by angle. Now, you're going to see a lot of these parallel lines. That means you have a transversal, right? So all we need is 2 angles. We need just 2 of them, 2 angle pairs to know that they're congruent. So we already see one right here. That's E. That's pretty obvious. But we also have a transversal cutting through here, right? And these are alternate interior angles here. So yes, because of alternate interior angles, we know that they are similar because we have 2 angles. For number 2, this is another 2 parallel lines, so you know we have a transversal. And we also know that L is congruent to itself, right? L is congruent to itself, and that angle is being used for both triangles. So then from there, we just need one other angle pair, and this one is corresponding. You can see that these 2 are both in this intersection. Let me do it in a different color so you can kind of see a little better. In this intersection right here, you can see that they're both the bottom left, right? So those are corresponding angles. So this would also be, yes, we have 2 angle pairs. Now you can do the same thing with angles where they actually give you the numbers, right? So if this is 39 degrees, and then we have this right angle, that we would add those together, that will be 129, and you just subtract that from 180, and that will be 51 degrees, which is the same as what we have over here, so that's got to be 39 degrees, and yes, we know that those are similar because all the angles are similar. For 4, so immediately, hopefully you can kind of see that we have 68, 54, and then 68 and 63. So those are the same. We really just need to find one of these. If I add 68 and 63, that will give me 131. And then I'm looking to add that or subtract that from 180, like what adds to get to 180, which would be 49. So that's definitely, if that's going to be 49, this is going to be different, and this will be no. We do not have 2 of the same angle pairs. We only have 1. So I'll let you do 5 and 6. I'll move on to side. These are pretty easy. All you're doing is checking to see whether everything is proportional or not. The big thing that I really want you to pay attention to is this right here. This is VU right here is 8. So that means that WU, the whole thing, is 28. You got to add them together. Same thing over here with the 15 and 6. WY is 21, whereas WX is 15. So that won't be too difficult for you guys. But I do want to show you some of these where you're not exactly sure which one is corresponding. So they didn't give you a similarity statement or anything like this because we're trying to prove similarity. And I mean, 11 and 12 and even 8 and 7 are pretty easy to tell, but 9 and 10, maybe you don't know which one goes with which. This is where I want you to do the longest side and then the shortest side, if I can spell, and then the last one that's there. So looking at 9, the longest side for this is 16. The longest side for the other one is 10. If these triangles are similar, then the longest sides are going to be corresponding. Then we have 5 and 3. Again, if these sides are similar, then the shortest sides are going to be corresponding. And then from there, we have 12 and 7. So you also notice that 10, 3, and 7, all on the bottom, there's that triangle, right? 16, 5, and 12, all on the top, there's that triangle. That's how it should be every single time. It doesn't matter if you put the 16, 5, and 12 on the bottom or on the top, but as long as they are all on the top and all on the bottom, that's how you keep things straight. Now, 16 and 10 would simplify out to 5/3, but 12 sevenths will not. So that answer is no. And you can do the same thing for 10, right? So our longest side in this triangle on the right is 54. Our longest side in the other one is 15. The shortest side over here is 18, and the shortest side over here is 5. And then lastly, we have 43.2 and 12. So looking at number 10, when you simplify all those out, they will work. What you can do, you can just take a calculator and divide them all and see if you get the same decimal, right? And it said if it's true, well, I guess we're not doing similarity statements here, but if you wanted to do a similarity statement, I usually just go from the shortest to the middle to the longest, just kind of like in increasing order. So if I had triangle RPA, that would be similar with shortest, middle, longest. So that will be RYT. So obviously angle R goes with itself. And as long as you keep those together, I mean, you could do all sorts of stuff. You could do PAR and YTR. You can do APR and TYR. You can do all sorts of stuff as long as they are, matching up together. Same thing with 13. Be very careful with this. We know that we do have side, and that angle is included. We know that, but sometimes people will want to match up 6 and 48 and 24 and 12. But that's not the case here, right? They've been inverted. So this triangle's been flipped horizontally and vertically, right? So we would have 48, which is the longest side up top, matching with 12, which is the longest side on the bottom. And 24, shortest, and 6, shortest. Well, I mean, if we only have SAS, then there's only 2 of them. But we can see that both of these will divide out to be 4. Yes. So that is similar. And you can kind of keep going from there. I think the only other one that you'll really need to, that you might get confused on is 15, where you have these parallel lines. And again, we have a transversal cutting through. So hopefully, even if I just erased all of this, if I just gave you these two, hopefully you can see that these are corresponding angles. And we do have the sides in between 2 corresponding angles, right? So if all else fails, just draw another diagram so that you can kind of hopefully see those 2, right? And then there's where you have these triangles. Feel free to extend it on like I did, override it, write it again, or write over it or whatever. And lastly, for number 18, same thing. GL, be sure that you be careful to see that that's actually 39,